Hello everyone, and welcome to today's webinar. I'm a virtual avatar in Developers Shore. I hope you're all doing well and ready to learn. Before we get started, I just wanted to take a moment to invite you to become a member of the Great Devs. As a member of the Developers Shore community, you'll have access to our job opportunities, activities, and future webinars. You can join us by responding to our invitation email or completing the form on our website. Also, a recording of this webinar will be on our LinkedIn page. Without further ado, let's dive into today's topic. Please give a warm welcome to our speaker.
So let me get started. Thank you, Vlad, for inviting me for this webinar. And today's topic is automated testing on iOS with XCUITest. And I am Suparna. I automate tests in PayPal right now, and before that, I have been automating for a decade. Like I have been in this industry for testing and automation in varieties of apps from more than 10 years now in different organizations. So to get started with, like I have been working with XUITest now from about 5 to 6 years, and I also have experience with APM, Selenium, C-Test, and several others. But I have found my passion with XUITest more in the recent few years, and that's how I have landed here. And I also write blogs and articles in different platforms about XUITest and several others QA environments, and I also like participating in several uh, events here and there. That's about me, and I can be reached out in the following links, that is in LinkedIn and Medium and GitHub, where I'm quite active at the moment. And to get started with, here's the agenda of today's webinar. And we will be starting with why XUITest, what are the specialities of XUITest, and how it is differentiated against other automation tools out there. And then when we should be using XUITest compared to other automation tools. And we will look into little deeper on shift left technologies and how shift left approaches can be implemented in mobile and how it helps compared to other approaches. And then we will also deep dive a bit on visual and UI tests with XUITest. And then we will also go through test automation pyramid while aligning with the XUITest technology on it, and how we can have the best out of all in the pyramid with XUITest, and how much of automation is enough in general, because that's a hot topic usually, that how much to automate. Automation is fine, but how much is enough is also one question that is highly um, asked. And then we will be looking into code coverage and other best practices to end with. So let's get started. Here, like why XUITest? We would have heard a lot about automation tools and several other automation tools like APM, C-Test, this Espresso, and XUITest also. So while there are several automation tools out there in the market, XUITest is particularly a first party tool from Apple, particularly concentrated on testing, especially the UI part. So this is directly provided by Apple in the dev environment, which is facilitated. So it is directly in the Xcode, where we use Swift and Objective C languages to automate here. So in general, what happens is that we have two components in this XUITest, which is like a test runner, which will comprise of all the instructions that like a set of test suits that will be having here in the test runner, which will allow and instruct what how to run what tests in the app. So we have two components on this XUITest. In general, I think this is almost common even in APM as well. So this is something very common. So what happens here is that we use both Objective C and Swift, depending upon what platforms we are comfortable with. The latest is Swift, and most projects use Swift nowadays. However, if we have to go little more complex, and still some of the projects are using some old old libraries, then also we can use both combination of Objective C and Swift in our tests and still proceed further. So that helps a lot. And then what is special about XCUITest is that it does provide record and playback facilities, which is not widely known to all. Because it provides record and playback, we don't really need to be an expert in XCUITest in order to use it. So we can still, as a beginner, rely on record and playback, uh, a feature of Xcode. Although this is for beginners, and most probably we will not use once we start getting familiar with XCUITest and its features. And then how does it complements unit testing? So what happens is that because we are in the dev environment where the development code is sitting, where the unit testing is getting written, and at the same place where the UI testing is also getting written, we happen to end up using each other's components. So lot of reusability is also done here. Apart from that, it is an additional next step on top of unit testing, making it even more comfortable, and it adds also further coverage. Common code, as we saw it, like here in XCUITest, it is at its best form and best utilized when it is getting uh, implemented at the dev environment, that is in the same GitHub repository where the development code is getting written, in the same place, just in a different suit. So that also has a lot of benefits. We will look into all those benefits slowly as we proceed today. And then how is it time saving? We will Because here we are not really concentrated on how to implement, or the setup hardly takes like few seconds. In fact, it doesn't take time. In fact, to start a new framework also, it may take a few hours at max, not more than that. In fact, the execution time is in seconds always. Each test what takes like at least few minutes in other platforms, let's say other tools out there, this usually takes like few seconds. In fact, even 1 second sometimes is a lot if the test is very complex. Otherwise it will be like zero point 0.3 seconds, 0.6 seconds, like that. And once one it's pretty fast, and we will see how. So the execution is one of the fastest or known out there. And it support not only black box, we can also go ahead and do white box and gray box testing with XCUITest. Now, this is happening because we are in the dev environment where we have the liberty to do and achieve maximum test coverage. So it is not just what we can see on the app, but it is also what the app is using in the backend. So this also enables us to achieve maximum confidence and maximum coverage as well on the testing side. So even though we cannot see certain components, if there are certain calls happening on the mobile end, let's say some SDK calls, some libraries are getting called out, even those can be tested and automated with XCUITest. Obviously, again, we have to combine both XCTest and XCUITest concepts while doing this, but that is a possibility which is so far not achievable in any other tools. And then we have no more flaky tests, and that is happening because Apple has made sure that we don't have any random test failures as such, as long we handle each of our test cases using the best practices. Also, there are some other mechanisms to achieve no flaky test items, like we either our test should pass or it should fail. If it fails, it has to fail for a reason. It cannot fail because of flakiness. So that is one standard principle we try to achieve in XUI which probably no other tool can claim to the extent of confidence that this tool can. Because again, there are certain other concepts where we can mock network layers and everything. So with that in mind, it is possible to achieve 100% non-flaky test, where we either if the test fails, then it has to fail for a reason. It cannot fail just out of flakiness. So that is one advantage of using XUI test, other than having it very fast. And this is ideal with shift left testing, as we are already in the dev environment. Already everything is at the latest, and if we have already shifted, it is ideal to have it running in that environment, instead of having your dev code and test code sitting somewhere else and then running it when there is some new commit happening or some build coming. Again, that will be a difficult and tedious effort, and that also does not benefit in the bug detection places. In this particular case, what happens, shift left helps us uh, at least fail the test cases as early as the dev has committed the code. And we will see what is shift left in detail today itself. But after that, if we happen to like test faster, as we are trying to achieve maximum test coverage. With maximum test coverage, we are also speeding up the testing time. With speeding up the testing time, it is like as soon as the dev has like let's say delivered the build, immediately it can hit the market every time. So that testing time, which takes like several days in certain projects, that can be eradicated. So that way, with each cycle, it happens such that you end up having reaching the market faster compared to your competitors as well. And then we have earliest bug detection and bug fix, and we will see this in detail as well. Now what is happening, how are we claiming that we are having the earliest bug detection, is that because already our tests are sitting in dev code, it is easier to run the test at the earliest possible stage. As soon as the developer has committed or introduced any issue, immediately the test fails, and that has to be addressed. Otherwise, without addressing it, we will not be able to proceed further. And then we have the fastest executions, as we said, like things work here in seconds and sometimes milliseconds, what runs in other places for minutes. um, and then we can achieve a more accessible apps here with XUITest. The reason being that we have more visibility on the app and the app's quality, and we have more visibility on the app's hierarchy and what part of the app is accessible more with each and every element. And that helps us achieve a more and deliver a more accessible apps. Now we will also see this in detail in the upcoming slides, but before that, let's know when we should be using XUITest. So there are a lot of questions. There are a lot of people who use. There are other tools without knowing what is the best for that particular product. Now there are famous tools out there, which is widely followed, but are they the right tools to be automated in that particular project is also a question. So let us also understand when we can consider XUITest, when we can consider, let's say, Flutter, or when we can consider something else like sorry, it's not Flutter, it's APM. So let's say there is a particular project where we have, it's a web view, like it's a web page, and if the in that website, if they are particularly reusing the components and using a web view kind of environment and reusing it in Android and iOS, then probably XUITest, Espresso kind of tools will not benefit much there if the entire setup is on web. So in such environments, Selenium, APM, and all that makes more sense. But in this particular case, let's say the entire app is built on native platforms, then it is highly recommended to go for XUITest. Uh, the reason being, if the dev has used native apps, it's easier to implement using XUITest to achieve maximum coverage. Now, can we also use React Native apps for XUITest? We can. There are some limitations. Again, it depends what kind of project it is, but it has been observed that even React Native apps with a certain setup can be automated with XUITest. Now, what happens to web views? Just because APM is a better tool for web views, in-app web views testing, it doesn't. Still, XUITest will give a good performance on this side of the app as well if we try to achieve it. So in our cases, when we use XUITest is when, let's say, the app is native with web views or the app is React Native with web views, we still can proceed with XUITest. But if the entire app is reusing some of the web components of some other website, then we may not go for XUITest, because we can use reuse some of the components of Selenium with APM and other places. So these are the places where we recommend people to use XUITest, and some places we do not recommend XUITest. So we should always look what is the right tool for which project. So that is very important. So also, let's say the app has several frameworks. In iOS they call frameworks, and as well as pods in some places. So if either of it, if there are some SDK integrations, frameworks that is getting imported, in those cases also XUITest benefits a lot, because we will be able to directly test using the components of the framework or the SDK. So that is also a very reliable part of the tool here. So in this particular case, what will happen is no other tool will be able to communicate with the frameworks on the UI level. Whereas XUITest not only communicates with the UI, but also of the all the components of the frameworks. That way we achieve maximum coverage as well on the testing side. Now, if the app is robust and dynamic, if the app is very simple, still we can go ahead and use other tools. But if the app is very dynamic and robust and complicated, and everything is native, and lot of things are happening not only on the UI level but also on the backend level, then also we will be recommending to go ahead with XUITest. And the reason being, here we will be able to achieve at least 90 to 95% of test coverage, whereas in the other tools we will not be able to touch at times more than 20-30%. um, and we will see some of the hows and why such statistics are coming in the upcoming ones. What are the testing levels? Now, one prime intention of XUITest that Apple introduced is that we should not be going to third party places. So having everything, both development and testing happening in the same place, benefits a lot to everyone. Not only it is fast, but it is also user friendly for all, and at the same time we are achieving not only speed, at the same time we are achieving maximum coverage, not only on the unit level, because anyhow unit testing happens everywhere on the dev environment, but the rest of the testing that happens is usually on the most of the time it will be on the third party, where we end up having lot of limitations. But here we do not have any limitations. Directly we can go ahead and automate using visual testing, integration testing, functional testing, non-functional testing. Everything is possible here. um, which is the reason we will be able to achieve more than 90-95% of test coverage, which is not possible anywhere else. In other places we hardly can cover few functional on the UI end, that's it. But here we can do almost end to end, not only what we are seeing but also what is happening on the app. So almost everything that is implemented can be tested here. Now, automatically what happens is that in many other places code coverage and test coverage is a effort that needs to be externally handled, such as even the reporting needs to be externally handled in many places when we automate using third party tools. But here Xcode itself provides us a mechanism where we just have to check and uncheck few options. In fact, one option for code coverage and one option for and reporting is even generic and default. So it is that simple to just measure the code and test coverage. We don't even have to spend any time in ensuring what are the code coverage measures and everything. It just does it by default. So those are some of the advantages of XUITest. Now, moving on to the apps, the kind of apps that we can consider for XUITest. So, if the app is, as I said, if it is a web view full of web components which is already getting reused in the website, already automated in Selenium, then we can use APM in those cases only if the same components are getting reused. But let's say the components are different in mobile apps. Let's say in this kind of a case where we have a QR code or something else altogether, and the entire app is native, then it is best for the team to implement on XUITest. The reason being, we will be able to achieve the maximum. Even QR code is something that is almost known to be a limited item in many platforms. But here also you can automate that not only with the framework but also by UI. Now, there are some other drawbacks in other places where people are having workarounds. How will they bypass this face ID or touch ID and these kind of authentication mechanisms? But here we can directly bypass, as we are already in the dev environment. It is very easily possible in a one line, in fact, to just test this and move to the next flow. So, and these are all automated in the past, and these are automated using XCUITest. Now here, if we consider apps like Google Authenticator and several others, like this is from Secure ID app, where we have tokens getting generated. Now in security apps, what happens every second, like every 30 seconds, 60 seconds, the tokens are changing constantly. And there are also places where we have to enter the right pin, right OTP and everything. So in those places also, if we try to use Selenium APM, many times the test will be flaky, and these kind of flows can take like up to 15 to 20 minutes in other platforms if we try to automate forcefully. But here it usually takes less than 1 minute, because again this flow might be a little complicated. In fact, even 1 minute is too much. It may take even few seconds. And how is this possible is because we can automate not only the UI but also the backend communications that is happening. Let's say there is a call that is getting called on the backend, which is the reason why it will poll, and then we will be able to just pass the request, receive the response, and then verify that response on the UI level here itself. So that way we can do much more, which is not possible in most of the apps, most of the automation tools out there, but it is possible in XUI at least in iOS, and the similar is also possible in Espresso on the Android side. So these are some of the major advantages. Now if we try to do this in APM or something else, what will happen is that we will end up doing one or two flows in this attempt, but it will take several minutes, more than 15-20 minutes, to get everything done via UI. And again, test coverage is something very controversial, which will not be able to be achieved in other cases. But here, if we just come for switch to XUI test, what happens in other places for 20 minutes, here it will be running in like 10x faster, and it will be ending up even before the other test finishes running. So that kind of efficiency and speed it can deliver, other than the reliability, where you also achieve non-flakiness. And then we have another app here. This is another app. This is a news app from one of my past projects. So here also what we can say is that this entire what happens in news app is that everything is dynamic. Every news is dynamic and news is changing in every second. So how do you test such a app? You cannot test on a staging environment where things are very dynamic. Let's say the staging also keeps changing, because everyone will have access to staging. What do you do in such cases? We mock, and we will see where all what all approaches we can follow. But here let's say we have mocked the API layer, so that we will be able to pass different mock APIs the way we want to test it, with different kinds of test data, and then we test the app. So this is also one of the highlights of XUI test, where brilliantly we were able to achieve like almost 95% of test coverage, and we had achieved almost bug free product out there. We never had any release where we had nightmares after the release. We always slept well after each releases, and that is possible only because XUI test helps us achieve maximum test coverage. And not only that, we will know where the flaws might be in the product and where there will not be any bugs. We always gain more confidence using that. So here we have another example where it is a completely React Native app. Only the entire news, that section that you are watching here, is fully React Native, and still it is sitting inside a native app. Now here also we were able to achieve entirely on XUI test, where the entire mock was implemented on the dynamic data. So that way, no matter which part of the app you use, still you will be able to automate and achieve maximum test coverage. And here also we had a very good performance on the app side. So there are like we just saw different types of apps having different kind of environments, and still we were able to achieve a very good test coverage in all of them using XUI test. Now let's move to the shift left approach, and what is the speciality of that, and how other tools may fail here compared to XUI test. Now let's say the developer is creating a branch, and then he starts implementing the feature whatever is supposed to be implemented, let's say in an existing product. So what happens is that as soon as the developer commits or raises a PR, depending upon how the project has been designed, let's say it is a commit, it's on commit level. So let's say the developer has committed or raises a PR, he cannot proceed further, because immediately the build, the unit test, the UI test, and if any other test is there, immediately it should be starting to run in the CI. And this is shift left, because before even if he pushes something else, before even he goes for a reviewer, as soon as he committed and raised a PR, the everything starts running in CI. And this should also, we should also ensure that this is time saving. It should not be time consuming. The CI also needs to be well handled. Let's say something fails here, it has to fail for a reason. It cannot fail for flakiness. This is also something that we need to keep in mind. And although if it fails, immediately there will be another push, fix of that. Let's say if something was broken, it can be fixed. If something was not broken, if everything passed, he can directly move to the approver and get it reviewed and merges items. So in the dev commit itself, what is happening is that before even the PR is merged, everything is already tested, at least how much ever is automated. So we have to ensure that maximum automation is also achieved. Now in many companies, what people do is that when the developer is committing with new changes, he also makes changes in the testing code, as well as he adds new tests as well, if possible. Sometimes the QA also does it, uh, and that is also popularly known as shift in sprint automation. And sometimes they also follow sprint minus one, again depending upon the project strategies one follows. So this is overall known to be shift left. Now in this very approach, many things can be tweaked out, and a lot can also change. Now although this is shift left, if we start using some production data instead of staging or mock data, immediately it can be reused for after deployment as well. So the flow helps and benefits a lot. So now we have something, the technologies that Xcode uses. Let's say it uses Apple, Swift, XUITest. Let's say we mock, we start using Embassy, and there are many others that we will see in the upcoming slides. And then we have several CI tools which supports XUITest to be integrated. And then if you want to debug, there are several other monitoring tools, post production, pre production, which helps us monitor the analytics, and if there are any crashes in case, then that also we can monitor using this. So these are some of the standard tools that we can use while we are using XUI test for testing. So this is the standard pyramid that we generally tend to follow. However, in XUITest, what we can do is it is highly recommended that we achieve the maximum test coverage in the unit testing level itself. So 60%, 60% is what it is expected to be covered in unit testing. Now integration also, we expect that integration testing also should be covering 15%, 15 to 20 at times, depending upon the type of app it has. Now what is integration testing? Anything on the API layer, anything on the SDK layer can be tested here. So it need not be something on UI layer. It can be on UI, but also it can be on the backend layer. Backend as in what SDK calls are making, what are the responses that we are getting. So each and every response can be tested based on the positive and negative test data we pass for each of the calls. So all that can be added in integration testing. So having covered this much here, we tend to decrease the amount of end-to-end testing or functional testing in the upper layers. So what happens is that XUI test, we will be either using lot of components from here, or even if we add any components, we will be adding what is not possible here, and that is most probably some of the UI, as well as sometimes integration of UI and unit. And in non-functional testing also, what we can do is whatever we have been automating so far, we can reuse those components in non-functional testing. And that is how the rest of the 10% also gets covered. So this way we will be able to achieve 95% of automation. At the same time, we will be able to achieve the maximum number of test coverage, leaving very small critical area for the manual testing, so that we save maximum amount of time for the release process. Now, if we also look at the speed of each execution time and scripting time, usually it is faster to write unit testing. That is also the reason why we try to achieve and add maximum number of test cases in the unit testing level itself. And the more higher we go, the more time consuming it goes. Although it's not that time consuming, but still compared to unit testing, it is pretty much time consuming and expensive. So we try also, that is another reason why we try to add very minimal end-to-end testing at the end, but have maximum base at the unit and integration level. So we know how unit tests work, but let's also target something here about visual testing, also known as snapshot testing and screenshot testing. Now, in snapshot testing, here we have added it in the unit testing level itself, and we will see why. In XCUITest, you also have certain frameworks available out there, which is provided by Uber, Facebook, and different others, where we have a provision to reuse certain ports to add more visual tests. So what happens here is that every UI component are visually tested, every change is visually tested, um, and it is on the screenshot level. So every screen is checked against a screenshot, and we will see how that is happening. So let's say there is a change anywhere. This is how a test looks like, and we can do testing on multiple devices as well. We can record and playback here also. That way we save also a lot of time in writing a script, as well as execution also takes like 0.1 second, 0.2 seconds, like that. And we can also notice that we are not launching the app here. And let's say we run a test and the test fails. Before the test fails, why we need to see why the test is failing. Let's say the initial development was having a blue button here, and the later it was modified or changed to red button by accident or something else. Now it is usually not possible that we check the colors in the UI test level. It is not possible. So what we can do is add a visual layer to it, so that even if there is a slight change, we will be able to detect it and see it in the highlighted area. So if you can see here, this is the recorded version where it is having the reference. When we run the test, this is what is found in the actual platform, and then it will show you the difference, where the difference is only showing you what has changed, and the test fails with this. So this way we will be able to directly pinpoint what has changed, and this is not possible to be tested in the UI layer in any most of the places. So this is one great place to have tested something within like not even 1 second. It is less than 1 second, and still everything can be cleared, and we save a lot of time here. And this is why this visual test is part of unit testing, because it saves a lot of time, and at the same time it adds a lot of value. And now here we have some references for visual testing. These are some of the standard and most famous ones which we can implement in our projects. And many times what happens is that people do not even go till XUI test. Many developers, if they have no time to write UI test, they end up writing only unit and visual, and they continue. Although that's not recommended, we should go for UI as well, and that is what we will see next. Now, we have functional testing here. So we have, okay, sorry, we have integration testing. In the integration testing, we do not have much. We just have to do some calls. Like we have to call and then check the responses against each, be it SDK or framework or library. The approach is the same for all. And then if we go to the functional testing, what usually the world follows is that everyone either hits the URL of the staging environment or the prod environment to test against the normal UI test. But in XUI test, you can do much more than that. We can also automate using SDK and API integration, as we previously saw. We can also mock the entire API layer, which will help us achieve the maximum reliability. At the same time, no flaky test. Only test will pass or fail, and if it fails, only for the valid reason. So that way we achieve maximum uh, coverage, and at the same time benefit also. Now, if we are doing UI test, there are different ways to debug elements. So before we write UI test, we also need to see some of the highlights of XUI test, which is here mentioned here. So there are different ways to debug elements in Xcode. One standard way is debug view hierarchy, and the next popular one is accessibility inspector. And then we also print the entire hierarchy if required in the terminal or console. And there are other third party inspectors. And this is one example of debug view hierarchy, where we can move the components as we want and check what each component has. Now, um, uh, we will also come to accessibility identifier here, where we can add accessibility identifier in the dev code, which is not possible in other places. Here, because we are in the dev environment already, let's say we identify in some place that accessibility identifier are missing. Let's say there was null even in the identifier place here when we try to debug. Then how will you either write automation test? Even if you write automation test, it may not be that it will remain vulnerable. So that way it will not be very stable. So we always need to see whether the labels are present, the traits are present, the identifier is present. And if it is not present, we have to go into the dev code. Either we can ask the developer to add accessibility identifiers in the dev code, or we can add our accessibility identifiers in the dev code. So there are different ways. Sometimes people use storyboard, sometimes people use functional development. So in this case, it is directly put up in the sample code. Now ideally they will be having some frameworks in place where they reuse components, but this is a sample code where we have already something written. Now what we went go and do is we add accessibility identifiers to the locations we see something is missing or we need to add something. So this is the highlighted ones are the ones where I went ahead and added accessibility identifiers so that it can reflect here, and that identifier can be reused for our automation. And there are other ways also where we can see how the hierarchy is appearing. And we can also see some of the other components while we debug. And this is how the debug view hierarchy is beneficial. This particular feature would not be this effective in other places. It's only effective when we integrate XUITest inside the dev environment. If we separate it out from the dev environment, it may not be very handy, and we will see why. Now this is another place where we are also checking how many layers the app is having, and what all it is using each component. And also we can check the other accessible components, what is defined and what is present in the app. This way, while automating also, we are able to verify and validate some of the accessibility related items in this level itself. So before we even hit and move ahead for accessibility testing, we are also doing an indirect accessibility enhancement while we are automating. And these are the other accessible elements of that. So this is one standard way. So indirectly, we are while automating, we are also increasing the accessibility of the element. Now we just saw debug view hierarchy. Now we will see another component called accessibility inspector. Now, this is usually available in Xcode itself when we start to achieve open developer tool, and then we have to open using accessibility inspector here. So once we do that, this is like a black box kind of environment provided by Xcode itself, where you try to locate the app, identify and debug the app as a third person, although in the Xcode environment. So here also, as soon as we click on this debug button or the locate button, wherever we tap, let's say right now here it is focused, so immediately you'll be able to see all the components. So this is also another way of checking the components of accessibility and the hierarchy if we scroll further. So although this is not that helpful compared to debug view hierarchy, this is also widely used in case the debug view hierarchy fails for any reason. Then there is another approach to access the elements of the app, and that is by using this PO print app debug description. Using this way, also we can see the entire hierarchy of the same app, of the entire screen in the same one page. Now, this is an example of a non-accessible product where the accessibility is not taken care. Nothing has been set on the accessible side. So this is how it will appear if an app is not very accessible, and we need to improve it right away, because this is not good for anyone. And how we can judge that is that how we can judge that is that the identifiers are missing, even the labels are very repetitive. What we are seeing here is also repeated here, is also repeated here, and this is not never good for any app. Now, when we are writing UI test, in general we also look into the frameworks. We need to write a reusable and optimized code. So this is one standard practice that most QA automation people follow everywhere, irrespective of tools. So this is also something that is used in page object model as well in other testing platforms. So let's say we have a development build, and then the unit test suite in another in the same project but in another suite. Then we have UI test. So the UI test should be using a framework which is reusable, and at the same time we are very it is well organized. So these are the components that usually follows. We do not really have that much time today to go through each of it, so we'll try to skip this. And if you have any questions on this, we can talk again on this particular framework part. So the next part is the network layers. The advantages of XCUITest is that we can choose our network layer, be it a mock layer, be it a API layer, be it a prod layer or a staging environment. Everything can be chosen, and accordingly we can reuse our existing code itself on different environments, and that way we benefit the most. As we discussed, the entire app is achieving enhanced accessibility because we constantly add identifiers and add labels, keep track of all the accessibility elements while we start automating. And while doing this, we also achieve maximum test coverage in CI. This is how we need to configure it. Let's say the build is running. As soon as the developer commits, the build should start running, and then we have the unit test running, then we have the visual test running, then performance is here, but it can be anywhere else as well. Localization also can be running here in a different suite. So independently, each of them will be running in each of the nodes each time. And then we can also configure our UI test to run in parallel, distributed parallel testing. That way we also can run everything in like 20 minutes, assuming that it's a very large project, out of which UI test can run effectively in 5 to 7 minutes as well. And that can be achieved for sure. And then the generation of reports is by default in Xcode. We just reuse the XC result file that is generated when all of them is complete running. Now the network layers, it can be achieved is that here we are using we can change the UI layer. Let's say we can switch between staging environment to prod environment, and then we can always write tests accordingly. um, then we have the mock layer. In this particular layer we achieve like 100% non-flaky test, although we need to ensure one thing here. We always need to ensure that the mocks are always up to date. We cannot test with an outdated mock, so we have to take care of the mock layer. As long the mock layer is taken care of, the entire app is in good hands, and we can sleep peacefully. And this is the reason we also end up, we can claim that we are achieving 100% reliable test here with the mock layers. And there are different mocks here that are available in the market, Nimble, Swifter, Embassy, and all of them are very reliable. All of them are very similar to each other, and they also work with both GraphQL as well as REST API kind of requests. So the API layer also doesn't matter. We can mock using both GraphQL and REST API layers, and they work effectively here. Then we have API integration. API integration is widely followed everywhere, so we don't really need to wonder about this. It is also used in the other world, but again, we can follow it here as well. The next part is SDK integration. This is also another highlight. Let's say there are certain components of the app which cannot be observed or which cannot be tested directly. So we can test indirectly. We can always bypass components and then receive the response and then try for automating that using the UI that is visible. And let's see how that is possible. Usually the developer would have already imported the SDK library. He would have already used something in the unit testing, most probably. We can just reuse that component into our UI test and integrate it. Now, this is one example where the SDK integrated UI test is provided. Now, here what happens, this is a UI test where we are combining both unit and UI. It is a general process where setup and launch is the UI, where the app is getting launched, and then let's say some of the UI components are getting tested visually, that is on the UI level. And then let's say there is a component which you cannot test visually because there is a backend call that is going on and which you cannot test on the UI front. So that time we do a SDK call here and we check the response of that SDK. We hit the server with the call because of the SDK integration, and then we wait for the response, which is usually takes milliseconds of time. We check that response and it auto polls and gives us the next response, which is on the UI level again. So this way we can always integrate both the UI and the backend in one place and still continue. And this works absolutely fine with SDK library as well as frameworks. When we say SDK, it is also the pods that is popularly known as. So it works with all of them. And this is one of the miraculous product. Although we need to ensure here that the hitting server should be quite stable in this particular case, so that we don't have a flaky test. Otherwise this is very effective. Now we have covered till here. Now what about the non-functional testing? So if we have accessibility testing, performance testing, so what is happening here is that we are using already what has been automated. So let's say we had a line called, let's say there was some lines dot app dot launch, which is a normal basic line in XCUITest. So app dot launch, what we can do is app dot launch itself we can reuse and use it in the performance test here. The same line which is already automated, we reuse that here and just let it run on the client side. So what is happening on the client side performance testing? It is continuously testing the app's performance, how it will run 10 times and check. Like 10 times is the operation that we provide. So if we want multiple times more, we can also define that. But based on that number of attempts, it also gives us a report how is the app performing each time. So like that, what has already been automated, we can reuse those and check how the app is performing when we run it multiple times on the app side, and how the even API is performing at times. All that can be verified here using just reusability, nothing else. And then including the localization as well. What happens, localization is also popularly known as globalization, internationalization and all that. So what is happening here, we can check the region, the language, the calendar, the locale, with just configuration which is already provided. Now accessibility we have already covered in places, but this is where it also shows identifiers that needs to be present, the labels needs to be present. If something is not present, we need to add it. And how we add, we already observed it, and after adding it should be shown like this. In this particular place we can see that the button doesn't have an identifier, so we can go and add identifier. That way it will be more accessible and at the same time more reliable. Now on the localization front, um, all we have to do in the existing test is that already whatever is automated, we just have to run it on different options that is available already. So what we can do, we have different places where we can configure this, either in test plan or in scheme, most probably in the test plan, which is highly effective. So we can create different test plans or configurations and then check against each of the localized item that we need. Once we localize it on this configuration level, then we can test against the app and reuse some of the existing localized strings that the dev team would have already added while they were implementing the localization. So this way also we save lot of time in testing localization on the UI level. Now, how all of this is managed in Xcode itself, what we can say is that each of it is getting uh, organized in each different targets. So let's say we have unit testing in one target, build in another target, snapshot test in another target, UI in another target. That way, when we have each segregated organized item or a suit, we have everything handled, and we then configure it in CI such that they run it in a segregated manner. That way, everything is well organized and at the same time well managed. And in the performance also, what is happening, localization also, what is happening, once we write unit testing, we write snapshot. Once we write snapshot, we write UI test. Once we write UI test, we reuse those components of that in localized and performance test. That way we are doing the maximum amount of coverage with very minimum testing efforts. Now also we forgot to catch up something here. We can do the same for iPhone, iPad and Mac. So this is not limited to iPhone alone, we can do it in all the Apple environments. Now the last steps that is happening is security scan. Security scans can be done internally as well as externally, although this can be most probably an external force that can also run in CI on the other level, which we will come shortly to. And then we have the manual testing, where we can do the rest of the critical area testing, where which cannot be automated at times. Let's say the upgradation, exploratory, and the other different tests that, let's say the tracking and other things can be also taken up here. So that what happens here is 95% of the efforts is automated on a daily level. Let's say the developer has raised five, let's say five developers have raised 5 PRs in a day, it has been tested 5 times. So that also helps you achieve maximum number of test coverage, and at the same time, if any test has to be updated, it is instantly updated without having reliability on the different member. Now um now yes, so now we also see the same thing, like everything is happening on the XCUITest framework level itself. We are not relying on something else. We are completely in the same Xcode environment where everything is happening, and at the same time we are able to reuse all the components and achieve maximum coverage. Now how most teams do it practically is that they run all the unit tests in every PR level. All the integration testing also can be done in PR level, PR as in the pull request. The functional testing also happens if it is a mock layer, mock server concept, then we do run it in PR level, because still we are able to achieve 100% reliability. The moment it goes to SDK and staging environments, if the server is not very stable, then there might be some flakiness, and that is the reason why they do not like to integrate with the dev PR. Although it can be achieved, it can be done very well if the server is very stable. If the server is not very stable, then probably it is wise to run it on a scheduled basis, let's say twice a day, thrice a day. So that the if there is any flaky test, there can be some retry mechanisms or something that can be done. Although this also can be well achieved in every PR level as well if the team handles it well. And then we have security scans and performance testing and all that, which can be running on scheduled runs, because this test takes time, sometimes hours, because security scans can take time. It can take several hours, if not days, and that is the reason we do not want to hold back our PRs from getting merged. That is another reason why we do not want it to be running in PR level. Now towards the XC result, so we have the result file here, which is automatically default available in Xcode. So we do not even have to integrate this. By default it is available. We can see all the logs, all the screenshots in every level, and then we have the coverage, the build, the setup, everything is by default available, which we do not have to configure. It is already available. So that way we are also saving a lot of time. Here also we just have to check the code coverage uh, option here, if we see. So only this one check will enable our code coverage in the app, and the entire app will be measuring the code coverage. I have just picked up a sample app where I have ran few tests and checked the coverage, where it was able to achieve 81% of code coverage. Now we will see each of it in detail. So what is happening in this, automatically everything is measured without me doing anything. At the same time, we are able to identify where how much code coverage has been done and how much is what. Now let's say somewhere it is 90% or 81%, we can go ahead and check in class level also, in function level also, what has been missed. So if we go to the next level, let's say we went to the class and checked what has been missed. So usually the code what is covered already is represented in green, if we tap on the right side of the highlighted area, and if we tap on the red highlighted area, we will be able to see what is not covered. So there is a total visibility and clarity of what has been done, what has not been done, what needs to be improved, without any efforts. All this is by default. So this is another example where we ran some negative test and we achieved like 53%. So each time we can see that it is dynamically generated code coverage report, which is very effective, and at the same time it gives a very clear outcome of what is happening. Now each of it can be easily integrated in CI with just one line commands. And if we try to improvise our CI integrations into a much better level, we can go ahead and implement and integrate with Fastlane, which is also very handy and popular in the iOS community. Now apart from that, we can also use browser stack and several other cloud devices which we have, but all of them have one common approach where we upload the app, get the response, we upload the test suite, get the response, we use the both the responses in the build command and try to run. So that is the usual very easy approach where all the cloud devices also can be running. Now what are the best practices we can have is that it is ideal to have developer doing testing and automation, but practically speaking it is very hard in complicated projects to have one person do everything. So although it's good to have the developer do build, test, automate everything, but it's always good to have a dedicated person as well for a dedicated item, so that that person automation is not compromised and continuously testing is happening, and it's always our tests are up to date. And if the tests are failing, it should not be failing for flakiness, it should be failing for a valid reason, so that we can update the test or the test or the build or the code. And then we have separate test plans so that we plan our tests or significantly well for visual, functional, non-functional, and everything. And then we also need to remember that although we are automating maximum number, we are not trying to replace the exploratory testing or manual testing. We cannot eradicate some of the manual testing efforts. We are here to support or achieve like 4 hour kind of release cycle where the build comes and in 4 hours you will be able to release. That kind of environment can be done, can be achieved, and it has been achieved as well in my past projects. So that is very much achievable. Only thing is that several days of manual efforts can be reduced to 1 or 2 hours, 4 hours. In fact, 4 hours also is pretty too much compared to the um, and then we have something for maintainability and usability. We try to reusable as much as possible, we try to optimize our code as much as possible. And with that, I think I have run out of time as well. So I'll summarize with saying that we need to do distributed parallel automation. We need to concentrate on in sprint automation as well as continuous automation as time proceeds. And then we it also boosts us confidence when we achieve try to when we try to achieve maximum number of automated suits. And when we it also helps us indirectly to reach the market faster with every automation. And it also helps us reduce manual errors, because that way if anything has been missed, it can be verified and it can be pointed in the automation itself. And time to time automation has proven that it can find bugs, that is especially the regression bugs are always useful. And then we have earliest bug fix, because as soon as the dev has committed, immediately the test has failed. So immediate, if there is a issue, immediate the bug has been fixed in the same PR itself, it has never reached the testing cycle. So that way it is also reducing the bug fix time as well. Our tests are more matured and reliable, and it is more accessible because of the common repository areas. Everything is much more easy and handy. And the maintenance also is very low here, because constantly our test and code is in sync and it is constantly updated. And then we have high reusability of code. As we saw, we are reusing each other's components effectively. Fastest test executions, fastest bug detections, we have covered that, and fastest scripting. So we'll, with all of that, it is assured that you will be having a pretty stable releases with such kind of plan, where you have achieved maximum coverage with very minimal efforts, and at the same time you have covered different types of testing levels, to be rest assured. Now I would also like to thank you for listening to me for so long. It's exactly 1 hour. I think if you have any questions for me, you can let me know in the Q&A session, or you can also reach out to me over LinkedIn.
Our webinar has come to an end. I'd like to extend a big thank you to everyone for participating, and a special thank you to the speaker for a captivating topic. It was a pleasure having you all here today. Have a great rest of your day.